Welcome to Design and Engineering in the St. James Fab Lab. Many of you are familiar with the Fab Lab, but briefly what the Fab Lab is, it's a lab that's part of an international collection of Fab Labs. And really the idea behind a Fab Lab is we have computer-controlled machines that are either additive or subtractive. So an example of an additive would be the 3D printer. Subtractive would be, if you can see in the background, there's a vinyl cutter, and then the white box over there is a small-scale CNC machine, and we have a large-scale CNC machine for bigger objects. And what makes this design and engineering class different from, say, shop, which maybe superficially it would have some similarities, is that this is really more about design and learning engineering principles. And certainly there is a component of building stuff because if you're going to design something, it's important to actually make it. But really most of our work is in design, and the making part, because it's made by machines, is integral, but more the end point rather than the point. And so what I mean by that is in any design, we'll first design in a digital format and use an iterative process. So we might make it with, say, the laser cutter, which is behind me here, out of cardboard before we make it on the CNC machine at a larger scale. But when you're doing computer designed making, that makes it possible because you can resize objects very easily within digital design. We're using CAD programs and whatnot. And you know, part of the engineering principle is talking about parametric design, which is the idea of like some things get bigger, but like the size of a screw stays the same. So, you know, the example they always use is if you're designing a scale airplane, you don't scale up the whole thing to the size of a Boeing jet, because it's the same whether or not you're talking about a half scale model or a full scale model. So these are the kind of principles we talk about. The other thing, and to use another example, and actually the first project that we've done, and it may seem like a kind of a simple project, we actually made a mousetrap car. And so the idea of this is you put back the spring part of it and you wind up the car and it then travels. But sometimes it's as simple as projects that are best for teaching the principles, particularly fundamental principles. So we use this project really to teach some design thinking skills. Also, something that's really important in this class is the digital portfolio, which I'm going to come back to in a second. But also just some fundamental design and engineering principles related to force and wheel size. And so, you know, you can take a simple project like that and really unpack it in a lot of different directions and make it a very valuable project. And ironically, part of what makes it a good project is the fact that it's simple, particularly as this first project, because, you know, we have kids who are coming in this class from very different backgrounds, of kids who already spent a lot of time in the Fab Lab to kids who maybe this is their first or second time in the Fab Lab and certainly haven't really engaged it. Having said that, I think all the kids that are in the class are really happy to be here and seem to really be enjoying it. Because this is a class, I need to address the issue of how the students are being assessed. Digital portfolios are really the most common way in which engineering classes assess students, because that's kind of what engineering a lot of is now. I mean, even at the college level, digital portfolios are really quite common as a way of tracking students and as a way of assessing it, because it really forces them to be accountable for their workflow, for what they're doing, what problems they're having, and also accountability to each other. And so the real drive home message that I have said to the kids is, if it's not on your digital portfolio, it never happened and it doesn't exist. So, you know, despite what they may or may not be doing in class, if they don't talk about it in the digital portfolio, if they don't document it, they don't get credit for it. And that's just how it works. That's sort of the challenging part of it, because that can be a really challenging thing for kids to learn how to document stuff and what's important and what's not important. And again, getting back to the concept of the mousetrap car, you know, I didn't want to make it harder for the students by bringing in something that was also conceptually difficult in its own right, when we're still learning just to do the basics of documentation and workflow, which are really important engineering principles and really important for engineers to document that. So that's the grading. So the really good part about this is that basically they have the opportunity to constantly improve on their digital portfolio all the way to the point where basically the end of the marking period where I have to give them a grade. Plus, you know, it's not cheating to look at what other students are doing. So students who are doing really great jobs with their digital portfolio, I mean, obviously the students can't copy what another student is doing, partly because they're not necessarily going to be doing the exact same. I mean, even if they're working on the same project, they're not necessarily having the same issues or the same challenges or coming to the same solutions. So it's not, you really can't copy, but it can be really helpful to look at another student who's doing it and saying, oh, I see, like that's what a really good digital portfolio looks like, and that's the kind of things you have in your digital portfolio. And obviously I'll have opportunities for me to give feedback. And I will then close by saying, if you want to get in touch with me, the best way is really email. You can contact me through Blackbaud, but I probably won't get back to you as quickly. And students know that they can obviously get in touch with me for chat. And I will end by saying, and don't forget to ask your student, your child, to share their digital portfolio, and you can see exactly what they're doing. And you know, that's kind of the whole point of a digital portfolio. It's a very public, I mean, not public in the sense that nobody can see them beyond who we share it with, but I mean in the sense that it's something that is shareable, and that really is an important component to it. So you're actually sort of fulfilling the sort of intent of a digital portfolio by asking to have them share it with you, and then you can see what they're doing, and I hope I will provide opportunities for you to talk about it. And again, if you have any questions, please do not hesitate to get in touch with me. Thank you, and I look forward to when we can all be back on campus together.